Great. Okay, I will turn it over to you, Farid. Go right ahead.
Sure. Can you see my screen?
Yes.
Perfect. Um, Hello, everyone. My name is Farid Seifi, and I'm representing this work on behalf of Knowledge System Lab at Department of Learning Health Sciences at um, University of Michigan's Medical School. Um, so we have developed a functioning platform for packaging, managing, accessing, and deploying knowledge objects. And we have developed, since 2018, we have developed 100 knowledge objects using this model. And through that work, we have identified limitations in the legacy model that led to further development of the conceptual model. And mainly, we wanted to address the question how we can make a knowledge object more usable. And the reason why, or what we identified as limitation in the legacy model was that it was only capable of supporting single API services or single API service as the only way to access knowledge objects. And in the new model, our model supports now multiple services with different types as different ways that a knowledge object could be accessed. And that's what we want to showcase here, comparing the legacy model with our new model and showing that now it's capable of supporting multiple services. So for the purpose of this demo, I'm going to use an example of personalized models for preventive medicine, mainly or more specifically a tobacco knowledge object that calculates the life year gain by stop using tobacco. But the focus is on improving the general knowledge object model rather than a specific instance of the CBK. So for this demo, I'm going to use a GitHub repository where we have taken snapshots of the life cycle of the knowledge object using GitHub tags. So I'm going to switch in between tags to show how a piece of code, a function, could be transferred into a knowledge object using our model, KGrid1, and then the transition from KGrid1 to KGrid2, and how it's capable of, it's capable of supporting multiple services. So let me switch to Visual Studio Code, where I have the tag 1 open. So here we have a piece of code. Tobacco.js is a function implementation of a function, which is a weighted formula. There is no kgrid in this tag yet. We just have a function, and there is a README file giving some information, a description, if there's a publication, definition of parameters, an example of how that function could be used. So now let's say a developer, a knowledge object developer, decide to use a KGrid model to convert that piece of code or use that piece of code in a knowledge object and make it available through API services. I'm going to switch to tag 2 where we have that knowledge object. Now we see we still have the tobacco.js file, the README file, and we have some other files added, the deployment file, a services specification, and a metadata file. And the metadata file is the core element here, where we have some administrative and descriptive information added, including title, contributors, description, and citation. There is another part that gives some development information, including where is the services specification, the deployment file, and the payloads. So this knowledge object is now, it could be used together with a tool that we have created, which we call Activator, to make the function, the knowledge inside this knowledge object available through API services. So let's quickly look at how that could be done. I have a command that will execute our activator, and also I'm giving it a pass to that knowledge object. So if I execute this, we have access to the activator on localhost, and if I open that, we have the Swagger editor provides access to some endpoints, but we can send post requests to this activator now, mentioning what endpoint from which knowledge object we want to execute, and we can provide some patient data, and then have the knowledge object execute the CBK on the data and provide the output. Or we can use this interface to just play and test the knowledge object. So I'm going to use one of the endpoints that will give me the list of knowledge objects that are activated. And here we have just one knowledge object, because that's the only one we have in this demo. It's described by its metadata, and then there's a section at the end describing the activation process or giving information about that. The status is activated, and there is another link we can use to actually send or play with the endpoints of this specific knowledge object. So if I put that here, I go back to the Visual Studio Code. In the README, I have one patient's information that I'm going to bring to this page, and then I will try it out, give it the patient data, and execute it. So that will execute that function implementation using this API, and then provide the life year gain by stop using tobacco for that patient. So far we have looked at the knowledge object that has been developed using KGrid1, and it only makes available the knowledge object through the API service. Next tag, we are going to look at the same knowledge object transferred using KGrid2, and we will only have API service available. At this point, we don't have multiple services added yet, but we will see how the model is capable of adding more services. And then in the next tag, we will add another service to it. So going back to Visual Studio Code, I'm going to switch to tag 3, where we have the knowledge object now transferred to KGrid2. The only change that is compared to the previous tag is the metadata. We still have the descriptive and administrative section, but we have a has service section added that has information about the services. This is an array. So far, we have only one service. That's the API service, and it describes some information like where is the service specification. The service depends on the knowledge. So knowledge can be described now as a separate element. And this also talks about the implementation, where the implementation is and what's the type of it. So this knowledge object could still be activated using our activator, but it, as we saw in the metadata, we are now capable of adding more services. So in next tag, we want to add another service, a command line service, to be able to access the knowledge object in a different way. So if I go back here and I switch to tag 4, we see that now we have a CLI.ts file added, which is implementing a command line interface. There's an input file added, which has 5 patients' information that we will use for testing. And the metadata has been changed. And the only change is that now in the has service, we have another service described here, a command line service, which depends on the same knowledge. And here is the implementation. So in order to run this command through command line now as another way of accessing the knowledge, I will just run one command that is available. We have 2 commands. I will use only one of them for the sake of time. It's a batch process command. We can provide an input, a pass to the input file, and then once we execute that, it will we just had an update available. That's interesting. So if we run that now, we are able to like the batch process command line executed the knowledge over the 5 patients, and we can see the output for all the 5 patients. So that's another way of accessing the knowledge object. And as we see, we have the value for all the 5 patients. 2 of them, of course, they are not smokers, so there's no gain in stop smoking because they're not smokers. So anyway, if I go back here, now we just want to show in the last tag that now that we have multiple services and multiple and knowledge as a separate element, developers may decide to structure the knowledge object in a way that they would be able to maintain it better. So we want to show that the files in the knowledge object could be moved around without any limitation. Our model is not in the way of the developers. So if I go back to Visual Studio Code and switch to the last tag, we now see that the same knowledge object has been restructured, a folder has been created per service, and the files related to each service has been put into the corresponding folder. There's also a knowledge folder where all the files related to the knowledge could go here, and all that restructuring just reflects, the changes reflect on the metadata, where we have, for example, the knowledge described will say where the knowledge implementation is, or the services that are included where their implementation are located. We have some links available in the presentation about the GitHub repository that I just used, and also some other useful links. So we would be happy to hear from everyone who's interested in our work. Thank you very much for listening.
Thank you, Farid. I do want to stop maybe and take a couple questions, and then we'll move on to Stan. So in the chat, Farid, there's a question that says, can you please define knowledge object and its limitation?
Sure. I just want to mention before answering that, I see my other colleagues in the room, so I would welcome them to unmute and jump in if they want to add a comment or answer a question. Knowledge object, the way we describe it maybe in short is a piece of code, as we just saw in this example, that is decorated with some other files like the metadata that would describe the knowledge implemented or embedded in the knowledge object. And now we have multiple services that could be used to access that piece of knowledge. So altogether, we call everything that I mentioned a knowledge object, and there are different ways to use it now. It could be used together with some with the tools that we have created that would provide access to the knowledge object through APIs, or other different type of services. We also saw the command line service. There could be any other type of service that the programmer may decide to add to their knowledge object. So the core element is the knowledge and the metadata that describes that knowledge, and also the services. That's what we refer to as knowledge object.
Okay, great. Anything to add from the Farid's team members? No? Any other questions now? If not, we can move on to Stan's presentation, and then we'll take questions there. And again, if you think of something for Farid, go ahead and type it in the chat and we'll get to it later on.
Thank you.
Okay. Let me pull up my slides and share my screen. Are you seeing my screen okay?
Yes. Mm-hmm.
All right. So in this presentation, I want to share some information about a new collaboration that's going on between Loink and SNOMED. Been going on a little over a year now, and actually demonstrate some early output, if you will, and a browser for the content. So I'll just jump in. SNOMED and Loink have had a relationship for some time, and some of it has just been overlap of people that were involved in both endeavors. But there was a formal agreement from 2013 until 2020 22, where there was a division of labor with LOINC focusing on defining observables, the names of things that you can observe, and SNOMED was focused on typically the values that you could see, but there was overlap in that in some of that, and that first agreement prohibited the creation of SNOMED codes that corresponded to LOINC codes, and what they did do is created models or created concepts for the SNOMED, well, yeah, for the LOINC codes, they created SNOMED expressions that represented the same meaning as a combination of multiple SNOMED concepts. It turned out that it was useful and it was a good experiment, but it wasn't what people wanted to use. If they were working in SNOMED, they wanted a SNOMED code for that concept. And so we created a new relationship with a different assumption. The new assumption is that we wanted to create a computable representation of LOINC, an ontological representation, if you will, and that we would do that as a SNOMED extension, and we would create SNOMED codes for every LOINC code and for every LOINC code part. So that's what this is about. So the idea is that we wanted to provide observable content, the LOINC content, to people who are primarily working within the SNOMED context. And if you will, the benefit to LOINC is that we would have a computable representation, which many people had asked for in terms of capabilities around LOINC. So just to say a little more, again, all of the LOINC content will eventually be in the SNOMED extension, and we will map existing SNOMED observables to LOINC codes and make new codes as needed. So right now there are some observable code, actually quite a few observable codes in SNOMED, and we want to get those back into LOINC, and we want to match them up to LOINC codes. And then we're mapping LOINC parts to SNOMED concepts again and creating new SNOMED concepts as needed. That's actually the biggest part of the work, is making all of those parts so that you can assemble the LOINC codes and make it ontologically computable. We're starting with lab data, and then we're going to do clinical data. We're going to do document types and names, radiology, orderables, survey instruments, etc. We will include group concepts in the extension. And for people that are, sharing data between an environment that's primarily using SNOMED codes in data instances and environments where they're using primarily LOINC codes for those observation identifiers, we created a translation table so that you basically can say, what is the SNOMED concept for this LOINC code, or for this LOINC code, what's the SNOMED concept? It's a very simple one-to-one lookup table for those things. And then just an editorial policy, if you will, that we decided on early on is that the fully specified names in the SNOMED file would be created consistent with the current naming convention within SNOMED. And that was so that the concepts that we create in the LOINC extension can be promoted to a US extension or to the global release of SNOMED without having to change anything about the fully specified name of those objects. So progress to date, we have created a preview release, so not an official release, but sort of a release that people can go look at and test out. It has between 23 and 24,000 laboratory LOINC codes that are in there. You can go to the site for this. There's a web page there, and we'll actually see this in a second. called loincsnomed.org, and then there's a browser to be able to look at the content. So we'll just jump in there. Going to the website here, and let me go full screen mode. And there's information here. It describes that there are places basically where you can go and make comments, submit comments and questions about this preview extension. And then you can go actually to the actual browser, which is what we want to do now. So if you've browsed SNOMED before, you'll recognize this. We're using the SNOMED browser, if you will, in here to browse the this new extension. So this is just a splash screen. If this is what would appear if I had typed in over here in the search the observable entity, and then you can see that there's 7,514 children. So that's children in this case is direct children. And then there are actually more things, because a lot of these things will have subtypes or things that are gathered under there. So that's how you get from 7,000 to the 24,000 is that do this. Now in this extension, it looks pretty flat. There are actually not that many interesting relationships, and that's because in this extension, and actually within SNOMED itself, we're trying to take advantage of the fact that this ontology is computable. And so we can do some things up here. For instance, if we want to look at this ontologically and slice and dice it according to a particular use case. So I'll just do a couple of things. You can come in and create an expression constraint language expression, which is just a language for how you can find and examine things in the ontology. And they provide a builder to make those kind of expressions. And so we'll go into the builder, and it has kind of its own language. Yeah, you get used to a little bit. But the first thing we want to do is say that what we're looking for are things that are observable entities. So we'll look for that. And it seems like on the first search, it's always a little bit slow. But what it's doing is going out, and based on the machine readable concept model, it knows the kind of entities that exist in this extension. And then you actually choose the exact concept, if you will, that you want it to start with. And so then you can add refinements. And so we'll add a refinement. And in this case, we want to search for things, and you sort of need to be familiar with the LOINC axes and with the machine readable concept model. But what we want to do is look for a component or observables where the component, and in this case, we want to say this is a component where we want to look at things that measure glucose. And so, we've got glucose here as a substance. If we choose that, now we've created an expression. We come back here and you can see the expression in the actual expression language that says We're looking for observables where the component is about a glucose substance, and then we can actually execute that query. And then you see the query results, and these are all now observable entities. This is glucose in blood 1 hour after a glucose dose with a person who's pregnant, etc. There are more general ones obviously down here. So that's a little bit about the expression language. We can go back, for instance, and say we wanted to add further semantics to what we're looking for. We can add another thing here, for instance, and we can say we want to define things that, glucose levels in urine specifically, for instance. Then we can say, okay, come in here and we'll look for urine as the direct site, and we come down to urine as a specimen type, and and then we can again go back here. You can see we've got a somewhat more complex statement now that says this is a direct site for the specimen type of urine, and we execute that query. And now all of these are things that are measurements directly related to urine instead of being blood or in some other body fluid. Now, I'm doing fairly simple things here just to demonstrate the capability, but there are lots of interesting things that you can do. For instance, you can search, say you wanted to find all of the kind of tests that identify acute or active COVID disease. You can do the same kind of thing that I've done already. You go in, you look for the component that has to do with COVID, and then you can say, actually what you're doing is looking, in that case, you're looking for different things. You can look for the RNA of the organism, or you can look for antigens of the organism. So you can specify those kind of things, and you can look and say, well, what are all of the RNA tests basically for COVID? What are all of the different tests that you could do for antigens related to COVID? So you can get more and more sophisticated in doing that, and then it allows then other kinds of reasoning. You can do this. There's an API to be able to ask questions of this ontology from a program. So you could use the logic and the support for clinical decision support as needed against this ontology. So I'll stop there and see if there are any questions. And if we have time, we could do another query or two, but I'd be interested if there are any other questions about this LOINC SNOMED ontology.
Hi, Stan. This is Ali. May I ask a question?
Sure.
Thanks a lot. This is great presentation, great work as usual. Will this new ontology or an extension to the SNOMED for the LOINC change how the technology binding works for FHIR, for example, defining value sets for course specification or implementation guides?
People can use it however it's useful, and that's one case where it would be useful. You could basically define, especially if you were doing intentional value sets, that is value sets that are defined by logic on the ontology, then this is basically an ideal tool for doing that. That you would make this kind of expression that we've been working with that defined exactly the values that you wanted to allow in a particular value set.
Okay, thank you.
You're welcome. a couple of other things that people have asked sometimes is, you know, the licensing policies are different between Loink and SNOMED. SNOMED requires either a national license or an individual company or person license in order to use the content of SNOMED. Loink is distributed with a license that is free. You still have a license, but it doesn't cost anything to have a license. The agreement between Loink and SNOMED is that this extension content will be free worldwide, even though it's in this SNOMED extension. You know, it's really an open, free resource, if you will, for people to use. Any other questions? I don't see. I see. There's things in chat. Procedures. Okay.
So I have another question. I'm sorry if it's out of context, but maybe just helping for me to learn about this. Were there some challenges regarding the mapping of Loink that were just based on the 6 axes to be an ontology which is different paradigm of modeling terminologies or concepts?
Yeah. I mean, there were all kinds of interesting issues actually that came up. And the other thing that a lot of you might know or are familiar with is that in the Loink database itself, the axes or the columns in the database are overloaded. And what I mean by that is that if you're doing observations like the ones that we're looking at now, the observation component is, you know, a substance or a cell type or something you're looking for or measuring. But if you're talking about document names are also in Loink, but the component's not an organism or something now. It's if you will, the service or what you provided to the patient. And so there's a recognition that we really need to make different formal models for different parts of the Loink content. The things that are purely observables are covered well by the current machine readable concept model in SNOMED, but the things like the characteristics, if you will, that you need to specify for document names or the attributes of document names are very different. They're, you know, again, the kind of service provided, whether this is a note or a consent form or something else. Another axis is the environment in which the document was created. Was it in a hospital? Was it outpatient? What's kind of the role of the person creating the document? Are they a nurse, a physician, a cardiologist, etc.? So there were other things, and just purely content things that also came up that presented interesting, and it's been great to work together between the SNOMED team and the Loink team on those kind of interesting modeling issues.
Okay, thank you. Just a follow-up question. Sorry for a lot of questions. Do you expect that in future, the first stop to define a new Loink concept will be the ontology-based one, not the axes one or columns-based one?
It'll always be created by the Loink group and then placed into the ontology. So the Loink group at Regenstrief has editorial control of the content. Over time, as you might guess, the way that the concepts are developed by Loink could evolve. We hope to get it, you know, make it more automated and do a lot of things like looking for duplicate codes in an automated way. But we'll always create the the codes in the LOINC database first and then create the concepts in the SNOMED extension. But there's work going on to, like I said, it probably means that the structure of the LOINC database is going to change over time because of the sort of the recognition that we really don't want to continue to overload the axes in the standard LOINC file.
Thank you so much. This is very helpful. Thank you.
Thank you. So a question in the chat, are there gray areas where to put the data, i.e. a SNOMED or LOINC? Will SNOMED always lead to enhance the interoperability? There is a clear agreement that LOINC has editorial responsibility for all observables. And so, and sort of the division of labor is that LOINC codes then are always those things that are saying, what did you measure or evaluate? Whether that's a serum glucose or a heart rate or something like that. And then for coded things like, what was the organism found on culture? So that part would be a LOINC code that would say what was the organism found on a culture, in a culture. And then the SNOMED code would have all of the, E. coli, other things. So I don't think there's any ambiguity about which things go where. What we're doing though is actually saying, all of that LOINC concept, all of those LOINC concepts will now have LOINC codes. So in people who have a system that is primarily using SNOMED codes for observables, then they have all of the LOINC content available to them. So it's again, the editorial control of the content still resides with the LOINC team, not with the SNOMED team. All right. Well, thank you.
Yes. Thank you, Stan, and thank you, Farid. Are there any last minute questions or comments or anything? Okay. Well, thanks, everyone. I think when you leave the room, you'll go back to the main session there.
Okay.
So thanks, everyone.
Thank you.